Okay, now let's repeat this same setup inside of Vex, how we can write the Vex code to achieve the same result. So in here we have this swap method. Let me duplicate all of this node tree, all of this network, node network, and let me rearrange some of these. And I'm going to just remove this attribute swap node. And in here we were just creating the line and we are resampling them and we are copying our sphere onto these points. And right now we have the uniform scale because we do not have p scale attribute. And onto the resample we have the curve view attribute. So now let's add an a attribute wrangle node in between, and let's add this. And in here now let's create our p scale attribute based on our curve view. We can create an p scale attribute by first defining the type. So we know that p scale is a float, so let's type f, and now the @, and after that the name of the attribute. I want to create an p scale, so now type the name, and now that is equal to, and for this time I want to set this onto my curve view attribute. As you know that we have curve view attribute present, and we can import the attribute in here by typing the name of the attribute. So first we need to type the @, which means that the attribute, and now just type the name of the attribute that you want to import. And I want to import my curve u, so let's type the name of the attribute, curve u, and now to end the argument at the semicolon. Now if I let go, and here as you can see we have the p scale. Now the p scale is driven through this curve u, and now we should have two attributes as before, curve view and p scale, and these values should be same. Let's go into the geometry spreadsheet, and here as you can see we have the curve view and we have the p scale, and all of these values are same. And same way we are just creating an p scale attribute and we are importing the values from curve view, and there is nothing happening in between. Let's add a fit range node that we have created in the attribute swap node, this one, fit range node. And to actually create this we have a Vex function. So in the Vex all of these nodes are called the function. Let me hide the parameter. So all of these nodes, this fit node and all of these nodes, these are called the Vex function if you are going to write the Vex code. And you can find all of the Vex function by going on to the help and contents, and as in here onto the reference tab. To the reference, find the Vex reference, and let's scroll down and we have another reference and we have these Vex functions. Let's click on it, and here we have a long list of Vex function. These are the Vex function that are available for you to write your code. And for this one I'm going to find the fit. So onto the filter I'm going to make a search query for the fit. So if I type fit, and here as you can see we have several different functions. We have efit and we have fit and we have fit01. Let's see the fit, and we have the help, and say takes the value in one range and shifts it to the corresponding value in a new range. So that is the function that we are looking for. Let's click on it, and here we have the syntax of this function. So we can type this. The float is a output data type, so which means that if you are going to fit your data type that is a float, okay, we can call this function like so. The name of the function fit, and we have the braces, and we need to define the value that we want to fit, and if it is a float, if you are working with float. And in here the next argument, these arguments should be separated by this comma, which means the input that that says that o min means that here we can see take the value in range o min and o max. Okay, so which means that o min are the input. O min, we will need to define what are the incoming values. Okay, minimum incoming and maximum incoming, and now these n min is the new minimum and new maximum. Same way, if you are going to fit your vector, we can call this function with the vector as well. We need the value, and here we have these three, min, max, min, and max for the vector. But right now curve view is in a float, so let's use this float in here. So what I can do, so first we need to call the function fit. So I'm going to just delete all of this. So I'm going to say at p scale, now I'm going to type the function name fit, and here we have the fit, and it should be written in this bracket, this small bracket. And now the first thing that we need to do, here as you can see, we need to define the value. So what is the value that we want to fit? And I want to fit the values that are stored in my attribute. So in here, I'm going to type the @ sign, which means take the values from my attribute. The attribute is called the curve u. So I want to fit the values that are present in the curve u attribute. And now to separate the argument, we need to press the comma. So comma, and we need to define the minimum value. I know that I have the incoming minimum value of 0. And now comma again for the next argument. And the next one is the max. I know that my incoming max value is 1. So let's type this and add another comma. Now we need to remap this into new value, minimum value and the maximum value. And here I can define my new value. Let's say I want to create a minimum value of 0.1. I don't want the values to completely 0. And now I can separate this with comma, and now we need to define the max, and I'm going to say the maximum value should be 0.5. And after that we need to close this small bracket. So let's close this, and to end the argument, add a semicolon. Now let me close this, and here as you can see, we have our starting value is 0.1. and I can change them. If I were to change, say, let's say I want this very first, this starting value to be, let's say, 0.2. If I were to change this to 0.2, and here as you can see, now we have these new values that are starting from 0.2 to 0.5. I can change this to 0.3 maybe, and here as you can see, we have this variation. And now we can create some parameters in here, because right now we are just manually entering our values. So what I can do, I can create a parameter, and as you know, we can create the parameter by creating a channel expression. So I'm going to press enter to move this line down, and at the very first line, you know that we can create the channel float with the chf function, and to actually store these values, we need to create a variable. So we know that the data type is float, so I'm going to type the float, the data type, and now the name of my variable. I'm going to call this one my variable name to min, and that is equal to now the channel function. So I know I want to create a channel in here, the parameter, and it should be float, so chf. Now start the bracket, and in here we need to type the name, and name is a string, and string should be written in colons. So let me add a double colon this time, and I'm going to call this one let's say whatever you want to call. I'm going to call this one min, and let's add this inside of this quotation. And now we need to close this bracket and also add a semicolon to end the argument. And now let's create another parameter. Let's add a float, and I want to store this in a variable. I'm going to call this one max, and that one, let's create another channel float, and I'm going to call this one max, capital MX max. I'm naming this. Let's close this with this small bracket and end the argument. Let's click on it, and now to actually create this parameter, we just need to click on this button. Let's click on it, and here as you can see, we have this parameter. Now we can pretty easily just use this graphical interface to set our values by using this slider. And here you can see right now these sliders are not doing anything. That is because we are creating these values and storing them in the variable, but we are not actually using them. So to actually use them, I just need to replace this value. You know that that is my minimum value, so I'm going to select all of them. So instead of manually typing this, I can just reference this variable. To reference this, just type the name of the variable. I'm going to type one min. So if I click, and now here you can see I have put use to my this minimum slider, because now I am getting these values from my this min variable. And same thing, I can do this for the max. Right now I'm manually typing this. I can just remove this and replace this with our this max variable. So let's type max. And now I can use the slider to actually control my min and max value. Okay, so we have effectively built the same functionality, the same thing that we have done inside of these by using these nodes. And now let's go into the attribute triangle, and here you can see we are creating this function fit. We are importing the attribute and we are remapping our input values 0 and 1 to our new min and max. We are getting these values from these parameter. And if you remember, if we go into the contents, and let me go into my vex reference and into the vex functions, and if I type in here and a fit, and down here you can see we have another function that is called fit01. Let's click on it. So the fit01, this function is a shortcut of this fit function. Fit01 means that we don't need to define our input range. So the fit01 assume that your input range is between 0 and 1. So which means we need to just type fit01 and now the value, and we only just need the new min and new max. We do not need to define our own this 0 and 1. So we can actually save our time by just creating an fit01 function. So let's see how we can do that. So in here I'm going to this one called this function fit01, and here as you can see we have this function menu appear. I can just pick function and press enter. Now it will be going to be written in my Vex code. And now we need to type this inside of this braces. And now we need to define the value that we want to remap. And as you know, I want to remap my curve view. So in here, I'm going to type @, which means the attribute. And now the name of the attribute, curve view. And now we need to separate the argument with the colon. And now we only just need to define the new min and new max. And I want to set new min, new max with values that are stored in this variable. So which means I can just type min, this variable name, and colon, and the max for the max value. And to end this, we need to end this small bracket and semicolon at the end for the ending the argument. Now if I click, and here as you can see, we have this exactly the same our result. I can play around with my maximum value, I can play around with my minimum value, and here as you can see we have basically the same function, but that is a shortcut, which means we are not defining the minimum, this fit01 assuming that your input range is in 0 and 1 range. So it's a shortcut function. Now let's see about the ramps. Let me duplicate all of this node graph and let me come over here. Right now we are remapping the value with this fit range node, creating some parameters, and we also have another node called the ramp. If I type here, we have this ramp parameter. If I add this, and that is another type of parameter that uses the ramps. So let me show you what I mean. So I'm going to just remove all of these parameter and the fit range, and what I can do, I can just input this curve view as an input and now output the ramp as an AP scale. So now we are not using the fit range function but the ramp function. Now I can go back and this node will create the parameter by default. Here if I enable the parameter, here as you can see we have some of these default settings. Now these settings won't do anything. These are just the default settings. To actually control these parameter, if we go back, here as you can see we have this new parameter ramp. This ramp parameter, this ramp parameter automatically expose its values onto this level. So whenever you create ramp parameter, its values will going to be exported into our this attribute warp level, this in here. So now I can define the color. By using the color I can set the values. So we know that the black mean the value of 0, so black represents 0 values and white represent the values of 1, and between we have these increasing values 0 to 1, so that we have this gray and we are traveling toward the white. So if I enable my this copy to points, and here as you can see now I have exactly the same look. Now I can play around with this color parameter, and here as you can see by adjusting the color I am adjusting my these values, but now I'm using these color. So for example I can add another knob in here by clicking on it, double click, and in here I can play around with the value. If I change the value, let's say dark in here, and for this one I'm going to, let's say, change this value to white, and by playing around with the ramp I can really alteract my this look. So these values will actually not do anything, this color value, because it's a float. We only grayscale values will gonna affect. I can use these color to set my p scale, remap our values, and right now we are using the color ramp, but onto this ramp parameter we have the option to actually change this to spline ramp. Here onto the ramp type, here as you can see we have the RGB ramp. We also have a spline ramp that is for using the floating point values, because p scale is a float value. Let's change this to spline ramp, which means that it will use the float values. All of these, my p scale has been set to 0. Let's go back into this level and let's see, and here as you can see by default our this spline ramp has been set to 0, and we have these knobs. We can remove them if you press and drag them down. That will just delete these knobs, so I'm going to just drag them down to remove them. And in here now I can just click and draw, and here as you can see now I am using this spline type ramp to remap our my p scale values, and this ramp represents our, let me select and drag to remove this knob. So the very first mean that our start of the line, so that mean we are starting with value with the 0. I can play around with this, and at the end in here I can play around with the value to set my p scale. I can play around with this and to really alteract my p scale value based on my curve view attribute. And right now we are setting the p scale attribute. We can actually change our this curve u position as well. Let me duplicate all of this node graph in here, and let's dive inside this attribute warp node. And for this time I'm not going to use the p scale. I want to just adjust my this y position, this line y position. As you know that this y position is 0, because currently we do not have any offset of this position onto the y. So let's dive inside attribute warp node, and this time I'm not going to create an p scale attribute. So let's delete this bind node. Let me bring this down, and in here I want to adjust my this line y position, this point y position. So we know that we have this p, it is a vector and it has three values, x and y and z. We can actually break down these individual components by adding a converter. We have a node called vector to float. So let's add this. What that will do, it will expect a vector. So we can give a vector p position, that is a vector, and that will separate all of these components, that is the x, that is the y, and that is the z. And we have the p as a output. We know that position is a vector, which means we need the vector. I can convert all of these float back into vector as well by adding a float to vector node. Here we have the float to vector. Let's add this. Now this will expect these three values, the x, y, and z. So I'm going to just connect the x and the z to z, y to y. And now this will spit out as a vector. So which means I can connect this into p. And here as you can see, right now nothing is happening because we are importing the p and we are outputting all of these values back. So nothing is happening in here. But what I can do, I can just not use the y position that is incoming from my original position. So I'm going to just remove the wire from the y. So just click and drag maybe in here. What I like to do, I like to use this curve view as a y value. So which means I can just connect this in here and to adjust this line position by using this ramp. And let me remove all of them, all of these nodes. Let's make this value to 0. And now here as you can see, we have the y value 0, which means no offset has been added onto the y. As I know that the curve view, sorry, let me go back. At the curve view, we know that the value of 0.5 means that we have the center, we have reached at the center of our line, of our curve. So which means I can add a knob at the 0.5 position. If I just add in here, and here we have the position. So I'm going to say add a knob at the 0.5. I can manually type in here. So now we know that we have reached at the very center of our line. And in here, I want to change the value. And here as you can see, I am pulling this point position from the middle. And I can adjust this knob to offset. And if we want to create a more, and as you can see, we have this fading type ramp. I can change the interpolation. If I come over here onto the interpolation, I have some of these interpolation. I can change this to constant, and that will make all of these constant, which means I think I need to change all of them to constant and this one to constant as well. And let me see, we need to play around with this as well. I'm actually bringing I'm playing around with this ramp to actually move only just this point up. And we also have some other interpolation method. I can change this to Catmull Rom, that is a smooth interpolation. And here as you can see, let's change the first one, this one, to Catmull Rom as well. And now here as you can see, I can play around with this ramp in a very smooth fashion. Now let's build this same ramp setup inside of our Vex as well. So let's do that in the next lesson.